All right, we're on number 29. What does the 1/3 power mean?
Cubic root.
The cubic root. Okay, so I'm going to get rid of this 1/3 power. I'm going to go cubic root of this guy right there, okay? The cubic root, the cubic root. All right, now, if I have stuff on the top and the stuff on the bottom, I can split them up individually so that I'm taking like the cubic root of 8, and then the cubic root of x cubed, and then the cubic root of 27. Do you see what I just did? All three of those pieces inside all have an individual each cubic root. When you're taking the cubic root, that means what times itself 3 times will give me that number? What times itself 3 times will give me 8?
2x over 2.
2. What times itself 3 times will give me x cubed?
X.
X. What times itself 3 times will give me 27? 3. And that is all. Pretty easy, right? Doesn't look real nice to begin with, but it actually comes out real nice. What? You would like something like that on the test? There are some easy ones on the test, I promise you. Okay? There are some hard ones too. Okay.
Bonus?
All right, next. 30 is a domain and range problem. This is the rational functions.
Well, I shouldn't think I'm not funny. That's a dumb.
If you want to know, this guy is one of those 1 over x things, right? Listen, 1 over x. But he has moved 1 unit to the left. Do you remember what that does to your equation if he's 1 to the left?
It's the bottom, +1.
Plus 1 underneath, okay? And he has moved up 1, which means plus 1 up here. This is what the equation looks like, except for one thing. He needs to be negative because he's in the other quadrant. So this is what my function looks like. Whatever. We don't really care. We just need to know the domain and we need to know the range, okay? And domain is left and right. This thing will go to the right forever and he will go to the left forever. I know because of these arrows. But will he touch every single value? No, he will not touch where this dotted line is, right? And that dotted line's at -1, so what do we put for domain? X is not going to touch -1. All right, range is the y's, up and down. He will go up forever and he will go down forever, but he will not touch this y coordinate of 1, right? Y is not equal to 1. Every other value gets touched except for those 2 values for x and y, yeah? That's your domain and range. Good? Do we remember how to do that? Okay. You don't need the equation. That was just for fun, but domain range, that's what you need to be able to do. Got it? 31 is the stats section. There's like 4 questions on this stat stuff, okay? 31. I'll read the paragraph. Listen. A fast food restaurant gives 25 of their customers a sample of the new milkshake and employees monitor their reactions. Underline that. Monitor their reactions as they taste it. Is this a survey, an experiment, or an observational study? Observational study, because I'm observing their reactions. If I was giving them the milk and asking for their opinion, that would be a survey. But observational study is what this one is. Not too bad, right? 32. In a study of 150 high school student responses, 78 students said that they were happy with their class schedule. Okay. So my happy people, happy with their class schedule, is 78 out of 100. We're happy with their class schedule.
Which can be simplified to 13 over 25.
Which what?
It can be simplified into 13
Sure,
over 25.
sure. Or it's 78%, whatever, right? Oh, 150. I'm sorry. Let's go back. Un momento, por favor. I was just seeing if you were paying attention. 78 out of 100 is how much? What percent?
52%.
52%. So 0.52 is what that comes out to be. I just divided, right? 78 divided by 100 is 0.52, 52%. Okay, hold on. Hold on. If instead there are 2,000 students and not 150, how many would have said that they were happy with their class schedule? I take 2,000 and I multiply by 0.52, and that is how much?
1,040.
1040?
1040, yep.
1040. Questions about how we did that? I have a string. Oh gosh.
What?
It's coming out of this brace. I don't know what I just pulled. But anyway, okay, whatever. Okay, next, 33. 33 and 34. Here is what you need for 33, 34. I'm going to put it off to the side over here. Ready? Write this down. Make sure you write it legibly. What does that mean? So you can read the dang thing, okay? Here is where 0 lives, okay? Then we have, I'm going to do a dotted line down the center. 0, dotted line down the center. You need to write this down, okay?
I'm not good at this whole bell
Plus
graph
1 is over here. Do a dotted line. Plus 2 is over here. Dotted line. Plus 3 is over here. Okay? This direction, minus 1 is over here. This direction, minus 2 is over here. This direction, minus 3 is over there. Okay? All right.
Wow, that's very
We're talking about standard deviation, right? So 0 is in the middle. That means you're on the average, right? If you add 1 standard deviation, you're in the next one, etc., right? Okay. What percent is from 0 to 1? That would be from like here to here. We'll do that one also. So if this is 68, what's from that little piece to that little piece?
34.
34% is from here to here, right? And same thing with here to here. Okay? All right. Then, do you know what percent is from like positive 1 to positive 2? You're close. 13.5% and 13.5%, which means overall, here is 95%. 95% from there to there. Okay? The last one, not the last one, from here to here is how much? 2.4%. I think it was like 2.35. We'll go 2.4%.
12? No, 13.
2.4% and 2.4%.
It's 99.
And that is
99.7.
99.7%.
2.4.
And this guy right here is 0.1% that lives beyond the 3 and 0.1% which lives beyond the 3, right? Something of that nature. It's actually 0.15, but whatever. Who cares? Okay? Good?
Yeah, who cares?
Can you explain number
32. Here in a minute I will.
No.
Yes, yes.
Was it
Okay?
1,040 students?
33. Once we get done, I'll go back. I'll circle back. Okay, so Trevin, remind me. All right. The number of tickets sold at a high school basketball game in a particular conference are normally distributed with a mean of 68.7. That means my bell curve right here, 68.7 is the average, and a standard deviation of 13.1. So I'm adding 13.1, adding 13.1, adding 13.1, subtracting 13.1, subtracting 13.1, subtracting 13.1, right? Okay, you see how that works to get these little markings right here? Okay, all right, what range of tickets sold represents the highest 2.5%? Do you see where the highest 2.5% is?
Yes.
Everybody from here and up. How many standard deviations is that?
2.
2. I need to add that 13.1 or whatever it was twice, right? That's that 2 cutoff mark, right? It is this point and above. So if I take 68.7 and I add 13.1, I get 81.8. If I add it again, I get 94.9. So what range of values represents the highest 2.5%?
44.9.
94.9 and
Above.
above. Anything above 94.9 is the highest 2.5%. You see how that works on the bell curve?
Greater than.
2.5%. 94.9 greater. Anything you could do greater than or equal to 98.9 and 94.9.
Like that.
Yeah. Sure. Sure. Pencil. I don't know. Questions about that problem?
How many are those on the test?
2. 34 is another one like that.
Can you tell me which number these two are on the test?
You'll know.
I'm skipping them.
You'll know. Okay. 34. Here we go. The number of minutes it takes Phil to commute to work each day are normally distributed with a mean of 18.6. That means
That's the middle of the bell.
that's the middle of the bell curve, 18.6, and a standard deviation of 3.5, 3.5, 3.5, 3.5, 3.5, 3.5, 3.5, right? What percent of the time does it take between 11.6 and 22.1 minutes to walk to work? Okay, let's fill in our 3.5. If I add 3.5 each time, this next cutoff mark would be 22.1. Check that. 25.6. 29.1. Yeah? If I subtract, I get 15.1. If I subtract, I get 11.6. If I subtract, I get 7.1.
Nope.
10, what?
8.1.
8.1.
8.1. 8.1. Yeah, you're right. 8.1. Okay? That's my adding and subtracting the standard deviation. Got it? I want to know 11.6, which is here, and 22.1, which is here. Uh-oh. How much is, they're not in the same spots, okay? So what percent is here?
That is
34. What percent lives in this window? 34. What percent lives in this window? 13.5. So approximately what percent lives between those two? 68 plus 13.5, which is 81.5%.
81.
Do you see how we did that? Okay, you cannot do those two problems unless you have this bell curve filled out. So make sure you have him. All right?
Okay, if you have like
That was not that hard.
I'm skipping.
34,
That was not that hard.
You have 34 and 34. That's 13.5.
You wanna see what I wrote on my
13.5,
paper? It says
and then
skip that
it's
hoe.
2.35.
Oh,
2.35.
wow.
I just did 2.4, 2.4, and
language.
0.1 and 0.1.
If we do,
But if you do the other, that's fine. I'll take that one.
I'd say the
Is
same
your
Because
thing.
that's
paper-
the
is
one
your
that we went.
paper band,
Okay?
Dylan?
Okay, so what was
Your
it
paper
again?
band?
What?
It
No,
was
it's not.
81.5.
Oh, like the car.
This is what we filled in right there.
Damn that. So it's 81.5, right?
81.5 for that one, yes. Yes. Good? Questions on 34
I don't know.
before we move on.
I don't know what to do with this.
What?
35.
Okay, that's what we're going over right now.
But
Find the value of sine and cosine and tangent. This is all new stuff, but this is easy. All new stuff, okay? And we want sine of theta and cosine of theta and tangent of theta, and all I need to do is write the fractions. Oh, okay, whatever. Call it x then. I don't care. It's just whatever it's named. So this is an x, right?
Okay.
Sine x, it's just a variable. It's just what it's called. They just use theta to represent an angle. It's the same thing. Yeah, sorry, I didn't realize that we hadn't used theta before. Theta, it's just like x. We can call the angle x instead. Whatever,
I'm
okay?
calling it beta.
Sure. I don't have this side of that triangle. How do I find that side?
Opposite.
C squared.
A squared plus b squared equals c squared. Which side? Which side is side C?
The side you don't know.
The hypotenuse, which is 30.
What a coincidence.
The side we don't know is which one?
B.
Sure.
Either one, it doesn't matter.
Either one, it doesn't matter. Let's call this guy side B, and 24 is this guy. So 24 squared plus b squared equals 30 squared, right?
Subtract it.
Okay, hold on. 24 squared is 7. I don't remember. 576. 576. Yes? Okay, I had to think. Plus b squared equals 30 squared. You should know that. What's 30 squared? 900, right? Okay. Minus the 576. And b squared equals how much? 324. And the square root of 324 is
18.
18. Okay? 18. So the 18 is this side right here.
So,
Okay?
sin is
Hold on. Just wait. Are we okay so far? Finding that third side.
Wait, what is it? Is it Sokotoa?
Yes, it's SOHCAHTOA. So write that down. SOHCAHTOA. Right? SOHCAHTOA. Got it?
Wait. Oh, wait.
SOHCAHTOA. That's what you need for this. Sine, cosine, and
So
tangent.
sine over.
Hold on. If this is x, which side is opposite angle x? 18. So label him with an O. Okay? Which side is the hypotenuse? 30. And the adjacent is 24. Okay, so now I go over here. And sine is OH, right? O and then H. So which number goes on top? 18. And H is 30. And that is all. 18 over 30. If you want to reduce, you can. I won't ding you guys. I ding my trig kids for not reducing, but I don't ding you guys, okay? Cosine is CAH. So adjacent goes on top. The adjacent side is 24. The hypotenuse side is 30.
Done.
Again, you can reduce if you want, but you don't have to. Tangent is OA.
18 over 20.
Opposite is 18. Adjacent is 24. That is tangent. That's all you have to do is write out those little guys. Got it? The fractions. Boop, 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 boop. What? Can we do lots more of those? Okay. I'm going.
This individual guy on your chart, is this the test piece? Or no?
Yes.
Yes?
Kind of.
Yes or no?
Well, he's going to be a test piece, but I'm going to try it with the real name. I have to put Amber Epley 2023 on there, just in case it ends up going good, and then I'll use it as a real one. Does that work?
Yeah, that works. Those brass plates, the...
Oh yeah, you can practice on those. Yes, yes.
Okay.
Do you know where they are?
Yes.
Yes, go get them.
What,
Yep.
thing
Okay,
gets
are we done with 35? Let's go to 36. We're solving for x. Here's the deal. 64 is my angle. Let's talk about x in relationship to 64. What is it?
Opposite.
Opposite. What about 11?
Adjacent.
Adjacent. Okay, so as far as SOHCAHTOA goes, SOHCAHTOA. Which one are we going to use? TOA, because we have O and A, right? Okay. All right, so I'm going to use tangent. Tangent of what? What goes inside of tangent?
No.
Nope. 64 equals, opposite is x, and adjacent is 11. Okay, last thing that I do, if I'm trying to solve for x, I multiply the 11 over to get it to go to the other side. And x equals 11 times tangent of 64, and that is something. What?
22.5.
22.5?
I don't know.
22.6. That sounds good.
Wait.
Woo.
Hold up.
Okay.
So we do 11.
11 tangent of 64.
Like last year, if we are done with stuff in 6th period, can we come start to take a
I don't care.
test?
Wait, so 64 times 11.
So,
Yep. Yep.
I got a negative number.
Yeah, same
You
here.
did?
I have study hall also.
A negative number. Let me see your calculator. Your calculator's in radians.
Just go
No,
mode.
you're in degrees.
Go to
11
mode.
tangent 64.
See, mine doesn't have that. Mine has normal, scientific, and engineering.
Ah!
Put that in my
Okay, good.
Sorry for the interruption. High school track, there will be no practice today. However, you're going to meet at the track after school to put hurdles away. Sweats and jerseys need to be washed and turned in to Mr. Arms tomorrow. That's high school track. No practice, meet at the track, and sweats and jerseys need to be washed
I'm gonna do the
and
next
turned in
one.
tomorrow. Junior high, your jerseys need to be washed and turned in by tomorrow also. Reminder, tomorrow is semester tests. It will be even, so we will start the day with second period.
We also start at 8, not 8:10.
why are
8.
they announcing this? If we're
I'm
starting
definitely
at
gonna
8,
forget that.
shouldn't that be
Kellen.
announced?
Wait, why are we starting at 8?
I'm gonna show up
Because
here.
it's Friday, so it's shorter,
I'm
so
showing
we
up
need the
here
extra 10 minutes for another test, even though.
That's retarded. Just don't do a finals day on Friday.
So we're gonna use so.
I have so much work to do. Actually, not really. I have Mr. Miss homework. I swear.
Nope, that's the last day schedule.
On for like 8.
Oh, I don't like number 40.
Last day is
I don't like number 40.
That's
40 don't look fun. I can do it though.
That's why next year school starts
I
at
can do like 3 seconds.
It does.
We're starting at 8.
Yeah.
What? If, what?
This is brass plate.
That's not how that works. Wait, did he say the jerseys have to be 30?
Yeah.
Jerseys, jackets, sweatpants, all started tomorrow.
Oh, really?
Which is good.
I don't know. I don't have the semester test schedule.
He's got a knife!
I don't know. Okay, 37. Let's go. Here we go. 37. Now I'm trying to solve for the angle, and this is SOHCAHTOA also again. SOHCAHTOA.
Why is
Okay.
X so?
Because I put it there, and I had to type over something.
So, it's so.
Why is it so crisp and the other one is blurry? Yeah, because I put it there. All right. What is 10 in relationship to x?
Jason.
He's the hypotenuse. Yeah. 5 is the opposite. So, okay, so opposite hypotenuse, which one? Sine of what? What goes inside the sign? X equals, opposite is 5, hypotenuse is
No one has
10. Okay, now, how do I get x out of there?
you and negative side.
Yeah, you do that inverse sine. Oh, inverse sine. Inverse sine. So x equals the inverse sine of 5 over 10. Do you guys know how to type in inverse sine?
Yes.
It's like the shift sign, or some people have like a calculator where you have to type the button or hit the button twice. Right?
0.52
Whoa.
or
What?
0.5.
It's 30.
It's like perfect.
You're in radians.
No,
So literally
mine only has
30.
math.
No
Mine
way
only
it's
has math
30.
and engineering.
Radians, degrees, you're in
Oh,
radians.
I didn't notice that. I thought it was always on top. And don't do that. No, I will.
I'm so scared.
Sigma.
But I'm not starting stuff with you.
Then yeah, you are.
There you go.
Thank
There you go. Now you're better.
What was
30
it?
degrees. Okay, good? 30
Do we have
degrees?
to put degrees on the test?
I don't care.
Be a little circle.
So no.
What?
Degrees is a little circle.
But my pen is fat, so, you know, my little circle turns into a dot.
We don't body shame in here. Right, Jacob?
Oh, that's.
Okay, 3 left. Here we go. You can't take a semester test without having to factor. I mean, it's just not a thing. Boo. 38.
X equals a 8.
Okay. X squared minus 64 is a difference of squares. Shh. It's a difference of squares. Listen, we're almost done.
8 and negative 8.
Okay, I want to break this down into 2 pieces, and when it's a difference of squares, I take the square root. Hold on. Shh, shush, shush, shush. The square root of x squared is x, and it goes there. The square root of 64 is
Positive and negative
8, and one of them is
Negative.
plus, and one of them is
Minus.
minus. But I'm not done yet because I have to set them equal to 0. So if x plus 8 equals 0, and I subtract the 8 over, x equals negative 8. If I set this guy equal to 0, then I add the 8, and x is equal to positive 8. And that is all. What? That's fine. You can do x equals plus minus 8. Yep.
So since these
Okay.
are so easy, can we just work on
No.
Why? I did 39.
We're almost done, kid. Come on. Okay? 39. What is this thing?
It's called a
He is a simple trinomial. Okay, when I do that, I am looking to multiply to get negative 8, but when I add them, give me negative 7. Nope, 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 nope. Oh, wait.
Positive
X.
and negative 8? Yeah.
Yep, x minus 8 and x plus 1. You're right.
I thought so.
Okay? Because negative 8 times 1 is negative 8, and negative 8 plus 1 is negative 7. Got it?
Yep.
Okay, if x minus 8 is equal to 0, then that means x equals
8.
positive 8. If x plus 1 equals 0, then x equals negative 1. There you go. Those are your 2. That's a simple trinomial. That's the only factoring that you have to do.
40.
Number 40. Number 40. What would you like to do first?
I can't remember what simplify the.
You want to simplify inside first? Yeah, let's do it. Sure. Okay. 4 and 8 becomes 1 and 2. Okay. I have x squared on the top and x cubed on the bottom. So I have 1 and 2. I'm going to have an x on the bottom when that cancels. I have y and y to the 5th, and that's y to the 4th on the bottom. But I'm not done yet because I have to cube everything, right? So I take 1 and I cube it, and that is 1. And I take 2 and I cube it, and that is 8. And I take x and I cube it, and that is x cubed. And I take y to the 4th and I cube it, and that is y to the
1 and
7 or 12. 7 or 12.
yeah.
7 or 12. Let's decide. Y to the 4th to the 3rd, or y to the 4th times y to the 3rd. Which one?
12. It's time. It's 12.
It's 12. Okay? Good?
So
That's all. Wonderful? Happy with that? Okay. Something like that. All right. It is on you to make sure that you have everything in your packet filled in. If you do not and are missing a day, those are up on Google Classroom. Should be up on Google Classroom. Okay? Do not come tomorrow and tell me that your packet's not filled in. I'm going to feel not bad for you. Okay?